Technology, we're using certainly a lot of it. Much like other architecture firms, we use it to help create the documents that we do, and then also to help people visualize the environments that we're creating, and it just gets more and more impressive in the capabilities, seemingly every year that we can do that. We're even to the point where we're creating apps, that you can have on your iPhone, to help explore and explain the design. But from the sustainable design standpoint, again, as we pursue this idea of high performance learning environments, that we can model things with respect to performance is getting better and better and easier for us to do in this day and age, and particularly because we work in so many different locations and so many different geographies and climates, that it enables us very quickly to understand the impact of the sun, the impact of wind on a particular site, or as we start to make interventions, what those impacts will be. So in some ways, it's the first exploration of that we do when we start what we call creative analysis is to understand those sort of climactic impacts on the architecture. Again, because we're concerned about energy, but also we're after sort of optimal daylight. So orienting the building properly is one of our first questions. In some ways, is what's the proper orientation here, or and if there's a counteracting issue of wind or whatever, that might start to generate different forms for the architecture. So I think that's been one of the most dramatic pieces, and but we just developed a design for a net zero high school here, though, and working closely with our engineers, who likewise have increasing capabilities to model the environment. What we were able to do is take that initial site analysis, that's driven from wind and sun, then to start taking that, from the site scale down to the building scale, and then into, the scale of the individual classroom, so that we can model certainly daylight, in the classroom, on a south-facing classroom, a north-facing classroom. We could start, then manipulating the facade. So in some ways, it's rather than just sort of drawing facades like, architects are trained to do in some ways, straight off the bat. What we're finding is, we're creating facades, through these analyses, and so as we start to manipulate the apertures, we can assess all the quality of the daylight and model it in real time inside the room, while we're also looking at the energy performance, in concurrence, and then we can start sloping ceilings and and making all these sort of adjustments, and really studying what the actual or theoretical performance is, and then so suggesting afterwards, once the building's open, we now have all the tools, thanks to the technology and all the metering that we have, to come back and say, is it doing what we'd modeled, and and really prove out the ideas. So we have what we've call the toolkit that we've built, which is full of these meters for acoustics and daylight and thermal comfort, and we've it's literally in a box, and we've got, I think, 3 or 4 of them now that we can evaluate multiple sites, concurrently if we need to, but we're also distributing them across the different offices that are working in schools as well, to ensure that these sort of analyses are available to everybody within the practice, so that we're all sort of pursuing the same goals of high performance, and then leveraging all the technology that we have to do so.